we're sort of in the stone age of the cloud native era, where you have to know a lot of low-level stuff. You have to do a lot of manual work to get the outcomes you want. And it's super overwhelming. The level of skills you need to have is really high. And that was the origin. I was trying to build containerized applications, but I didn't want to do it the hard way.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for open source projects with a focus on CNCF sandbox, incubating, and graduated projects. Hi, I'm Marc Campbell. Together with Benjie DeGroot, we publish the Kubelist newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable software vendors such as HashiCorp, Puppet, Harness, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. Benjie is the co-founder and CEO at Shipyard, where they enable teams of all sizes to build, test, and deploy faster and more reliably via their ephemeral environment management platform. Get started with ephemeral environments at shipyard.build. The Kubelist Podcast is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. If you're interested in being a guest on the show or you would like to suggest a project, find us on Twitter at ReadKubelist. Finally, sign up for the Kubelist newsletter and read previous issues at kubelist.com. On this episode of the podcast, Benjie and I were joined by John and Kyle, the co-founders of Slim.AI, to talk about their product that helps explore, understand, and secure containers. This conversation really gets into John and Kyle's background and how they view container security, and then goes on where John talks about and explains the 3 principles that they see to ship a secure product and how Slim implements this. Hi again, and welcome to another episode of the Kubelist Podcast. Today, we're here with John Amaral and Kyle Quest, 2 co-founders of Slim.AI, to talk about their popular project and service. Welcome, John and Kyle.
Hey, thanks, Mark.
And of course, Benjie's here. Hey, Benjie.
I'm here. I'm excited about KubeCon. We're recording this right before KubeCon. I'm getting excited, Mark.
All right. Well, let's dig in. So normally we like to get started with just some backgrounds. John, do you mind getting us started by telling us like your background that led up to creating Slim.AI?
Sure. My role at Slim CEO, and I come from a 30-year background in developing products and building technology. These are software products, of course, mostly SaaS throughout those years. Of course, 30 years ago, there wasn't any SaaS, but I've been building software products that are mostly in the cybersecurity and networking space. And going back in time, most recently, prior to Slim, I was the head of product at Cisco Cloud Security, which is a really big cloud security division of Cisco. Before that, I was at a company called CloudLock, which was acquired by Cisco. And we were another cybersecurity SaaS company in an area called CASB, Cloud Access Security Broker. And then going back in time, similar roles as either CTO or head of engineering or head of product or all of those, depending upon the role in companies. And a bunch have been successful. I've been acquired several times, and a couple of really big ones, notably TrustWave, which is a managed security services provider. I was SVP of product there, and that we sold that to Singapore Telecom. So I've been pretty involved in building cybersecurity tech for a long time. I have a background in software and computer engineering, undergraduate, and I got an MBA from MIT. So been mostly on the business side and product side now for several stints. And that's also true at Slim.
Great. Yeah. And I think we're going to dig into a little bit, there's a super interesting background of the business side, but like pretty technical too. So we'll kind of put that over here for a minute and come back and chat about it. Kyle, the same question. Would you mind kind of sharing with us your background that led up to creating Slim?
Sure. I'd say I'm a builder and a breaker. So I've been building cloud native apps since the early days of cloud native, early days of AWS and all of that. That's when it all started. And on the other side, I've been involved in security in different capacities for quite a while. So I like breaking stuff and I like doing the opposite. So it's kind of a combination of those two things that led to the origins of Docker Slim and the tech behind it. And, what I have observed, building applications for the cloud and containerized applications kind of served as an input for the initial idea.
That's awesome. So let's jump in and chat about the product. So generally, like the folks listening to the podcast are pretty technical. So don't be afraid to dig into like the lowest level that you want to or whatever. But like, what is Slim? What does the project do right now?
I can start and then I'll hand over to Kyle.
Sure.
So one thing we didn't say about our backgrounds, like together, is that we've been working together for like roughly 20 years on and off and mostly on. So I estimate like something like 15 of the last 20 years, approximately, Kyle and I have been working together at companies where we, build cybersecurity products or, build deep tech around SaaS and cloud native. So we didn't just kind of like meet on the street and start this company. We've known each other a while and building really great stuff for a while together in our own capacities. At a high level, Slim is all about providing developers the ability to understand, evaluate, and quickly build secure containerized applications. And we have a open source that Kyle will tell you all about and give you his perspective on. And we have a SaaS platform that's available and free today for developers that allows them to really explore, understand, and secure containers, whether those containers are containers they build themselves or containers they consume from public registries. And so the high level, value proposition or belief or use case families that we're trying to attack are inherently, software supply chain security is a real problem. Understanding and securing containers, using container best practices is a key factor in being able to limit risk in deployed applications. Reducing attack surface of containers, hardening them, removing vulnerabilities, really understanding how they run so you can secure them appropriately. It's pretty hard work and it takes a lot of expertise if you don't have good tools to do that. And we've created some really awesome tools that can do a lot of that stuff for you automatically and give the power to the developers so they can build secure apps from the start, right at the point where they turn it into something that will run in the cloud. Right there, they can make their containers more secure. And we think that beats securing them after the fact or later or having poorly composed containers, which is a way harder proposition to fix after the fact. So that's at a high level what we're all about. And I mentioned we have this open source project. Kyle's the creator of that. I'll let him kind of dig in there and tell you all about it and then tell you about our tech as much as he'd like.
Sure. It's a standard way to start a project, solving your own problems. Where I had a problem, and technically it's a general industry problem. But the new cloud native applications, there was a new way to build and deliver them with DevOps. And there are many definitions of DevOps, but one of my favorites is you build it, you run it. But what does it mean? There's a lot of potential, and it empowers engineers to own the application full cycle. But it also means that the app developers are now expected to be infrastructure experts, and that's just not realistic. So there was this disconnect between the theory and reality. And we're technically still in this phase where we are sort of in the stone age of the cloud native era, where you have to know a lot of low-level stuff. You have to do a lot of manual work to get the outcomes you want. And it's super overwhelming. You look at the CNCF landscape, so many different technologies and tools and all of that. And, you just trying to know Kubernetes is a mission impossible. So there's a lot of low-level knowledge you need to have, and the level of skills you need to have is really high. And that was the origin where I was trying to build containerized applications, but I didn't want to do it the hard way. Kelsey Hightower has this awesome Kubernetes the hard way. And I think there's a lot of that in the cloud native space where you're doing a lot of stuff the hard way. And I wanted to find this easy way or a straightforward way where I could get the outcomes that I wanted. And that's production-ready containers and secure production-ready containers without doing a lot of manual work. And so I ended up leveraging my security background in order to automate a number of activities that had to happen, creating hardened and production ready containers. And that's how Docker Slim was created. And it was created during one of the global Docker hackathons that they hosted at the end of 2015. And then the project got a lot of traction because this is a problem that others experienced as well. So, and it just kept growing and growing from there.
I remember those early, I don't remember if it was 2015 or, or which year it was, but back then those early Docker hackathons, it was, obviously pre Kubernetes, Docker 0 point whatever days, and it was early and it was fun. Lots of interesting and fun stuff was being built then. I mean, like now too, but it was still very, very early in the whole ecosystem.
Yeah, exactly. And I would say we're still early on. It's still not mature. And this is the exciting part because there's a lot more to do and a lot of opportunities.
Yeah, I'm excited to talk about those opportunities. One thing I wanted to ask is I'm a noob when it comes to Slim, but I've been following Docker Slim for some time. And I always kind of thought of it as more of a way to make my containers a lot more efficient. Obviously, when you reduce the surface area of the libraries and all that stuff, obviously there's a huge security component to that. And you guys have both been talking about the security angle, which totally makes sense. But I just thought for maybe a second, can you tell us a little bit about some of the efficiencies you might get just as an operator if I were to run my images through Docker Slim? It seems like there's also some speed gains to be had. Is that accurate, or is that just a misassumption by me?
There are a few. And I'll kind of parse out the various value propositions. The first is, Docker Slim and Slim are Swiss Army knives of container evaluation, analysis, and optimization, or we use the term hardening as well for what we do to secure them. It's not uncommon, and in fact, I think it's generally common that folks who build containers don't efficiently or effectively scrutinize the code they have inside the containers. They sort of have to know what it takes to get their container to run, meaning that they add the parts that are necessary to run, and that's normal when you build code. You can't miss something that makes your app run. But what they generally don't know is the parts that they don't need. And it's pretty common when you build from a base image, like a base OS image like Debian, and you add in Node and developers want to go fast, so they want to build things with images that have convenient tooling or robust package sets, etc. Those things from our systems have scanned literally millions of containers. We see that on average, there's way more files than necessary to run the app, and there's all the risk and baggage that comes along with that, including inefficiencies and speed and startup times, and of course vulnerabilities and risk surface. So, container best practices state 3 high level things, right? And these are the kind of maybe the 3 core ones. So you should know what you're shipping to production. You should minimize what you're shipping to production to only those things you need for your app to run, and you should remove as many vulnerabilities as possible. There are all sorts of operational and security ramifications of those 3 things. On the size part, what we've seen is as you reduce container size, you get operational efficiencies and even sometimes cost efficiencies, certainly in CI/CD pipeline times. Scanners work faster on smaller containers. Things flow through your networks faster. They pull faster, they push faster. When they load, if you're using something like serverless containers or even using Fargate or one of these container services on popular IaaS systems, those containers, you're charged for those containers when the service asks for the container to load and then start up. And what we see for ephemeral workloads is that if a container has a long startup and load time, but a relatively short ephemeral working lifetime, that your bill can actually reflect more cost on the startup and load than it does on the actual lifespan of the working container. So there's these efficiencies and speed and performance gains that can be gotten depending upon the context. And then storing very large images around everywhere builds up over time, and it causes drag on your operation, on your developers' desktops, in your CI/CD pipeline. etc. And storage cost isn't free either. And depending upon the system you use to store your containers, that can be more or less impacting. On the security side, I think the effects are even more profound. With software supply chain risks today, there's a lot of scrutiny on vulnerability counts. Vulnerability scanning is really prominent. And folks who create containers are getting a lot of pushback from container users. Think of that as, hey, I ship containers to my customers as the software I expect them to run in their SaaS. Or I'm running security for a firm's SaaS. I'm downstream from the developers, and I have to reach a certain security profile for the running systems. The scrutiny caused by Log4j and even the other popular kind of large scale supply chain attacks like SolarWinds have caused a heightened sense of urgency to make vulnerabilities go to zero. That's pushing back on developer teams and causing a lot of churn and a lot of work. And if you're a company that ships containers broadly to the internet, for instance, think of any foundational infrastructure container that you can find on Docker Hub. Those publishers are getting a lot of interaction, a lot of feedback, and a lot of pressure from users to have vulnerability-free containers. And it's not easy to make containers vulnerability-free. And so that dynamic is causing a lot of interest in use of our tools, which help you remove vulnerabilities and unnecessary space and adhere to those 3 best practices I talked about. Getting those to happen as you build, but automatically through DevOps is a really big value proposition. So size and security come along together as you make these optimizations. Kyle, do you want to add to that?
Yes, I'll add with security. So one of the interesting things in security, one of the concepts in security that's super desired is proactive security. You want to be proactive as opposed to reactive. And if you look at the traditional vulnerability management, this is a reactive security control. You have vulnerabilities discovered, then your scanners will have checks for them, and then they will find those vulnerabilities in your containerized application. So, that's great to do. It's important to have the reactive controls, but it's also desired as much as possible and realistic to be proactive. And one of the fundamental approaches with Docker Slim and Slim is about proactive security. So you throw away the stuff that you don't need, and that's proactively eliminating problems, reducing the surface. And this is this is one of those things that's hard to do manually, traditionally. The idea of proactive security and the concept of least privilege existed for decades, but it's the implementation side that's been tricky. And trying to automate that is really a game changer, and that's what we're trying to do. And I think the same is true for the size and other hardening activities. It's super low level, requires a lot of domain knowledge, and it's time consuming. Optimizing the size so your images push faster and they start up faster and all of that, and being able to automate that is super powerful, because what you need in production is different from what you need when you're developing. When you're in production, you want to have as little as possible in your container, but when you're developing, you need developer-friendly containers so you can develop easier, debug easier. And if you look at those kind of developer-friendly container images and all of that, Ubuntu and Ubuntu-based images are pretty much it. And I'd say Ubuntu and to some degree Debian has been the operating system of the cloud. If you look at the last 10, 15 or more years, they dominated the DevOps scripting space, all those cookbooks, recipes. A lot of it was built for Ubuntu or Debian. So there's a lot of this critical mass that developers or DevOps engineers are used to leveraging to build their environments, either containerized or non-containerized. And there was critical mass and gravity around that. And that was another kind of driving force behind the original project, because I used Ubuntu images to build containers at that time. I didn't want to change the config scripts, all of that, throwing it away, going with another operating system was a big ask. Just going from one version of the same OS to another one is a significant effort. So, being able to use what I had was super important, and that's what I was able to achieve. I could still use Ubuntu-based images and then get the outcomes that were necessary to have production-ready containers. So this is the developer experience side of that is super important as well. It's not just about pushing the images faster. It's also about developing faster as well. And you develop faster in an environment that's more developer-friendly.
Yeah, definitely. I mean, quick question for you. It can be just a yes or no, but back in the day when I was doing a little bit more developing, I'm not really anymore, but Alpine, that was the answer. Like, use Alpine, super low surface area. I feel like Ubuntu Slim is kind of the new hotness now. Just if you're a listener and you're like, I want to get started, I'm going to get Docker Slim integrated soon, but I'm just starting today. What's the image that you, just as obviously an expert in this, Kyle, what would be the image that you think you start with now? Ubuntu Slim? What do you think?
I'd still go with whatever standard images they have. If you look at the language-specific images, for example, for Go or Node or Python, the main ones are Debian-based. And because of that, there's enough critical mass around that. So that's the best thing to go with.
So don't use Alpine anymore. So I used to tell everyone just use Alpine, but Alpine's I'm pretty sure Alpine's kind of...
So here's the deal with Alpine. I think it's an awesome project, but there are certain things people are not aware of. There are two types of Alpine users. The experts who know the ins and outs of Alpine and they understand the trade-offs. And the newbies who heard something about it and they try to use it and it seems like it works for them. And it's like this for a while. And maybe if you're lucky, you'll be fine. But there's a lot more to know about that than just that. For example, the package manager ecosystem. In the commercial application development space, you don't always control the operating system and the package manager because you work with third-party vendors and they give you RPMs, or you need FIPS encryption, and because you're going after a compliance mandate, either a government mandate or some other commercial mandate, and you get FIPS encryption with Red Hat. You don't get it with Ubuntu or definitely not Alpine. So you end up with the operating system you have to use. And that's a big deal. So sometimes maybe you can use that. But there are a lot of other interesting things to be aware of. And the problems that, like one thing about Alpine is that it's not a standard Linux distribution. It's not a GNU Linux distribution, which is probably the number one thing people are not aware of. So what does it mean? It means it's not compatible with your Ubuntu, Debian, Red Hat operating systems. And a big part of it is the libc component package. That's the foundation for a lot of applications. They have their own Mosel libc implementation, and it's not binary compatible, and there's a lot of interesting things around it. So, and because people who hear about Alpine, they see that, oh, the image is small, I'll just go use it. Again, maybe your use cases will be just fine, but there's a lot of unknown that you need to be aware of.
Right. So there's no magic bullet.
Yeah,
is the truth. Back in the day, I felt like Alpine was a little magic bullet-y, but of course, for all the things. For a lot of the reasons, and it's really helpful to lay them out like you have, of all the things that you need to consider. One other thing I wanted to just poke on a little bit, and then we're gonna switch gears a little bit, is I think it's really interesting. You brought up the point of development being a very different environment than production, and I think most of our listeners understand that. But I think really cool technology that's coming out with, I think it was out of beta for 1.24 is the ephemeral containers that attach. So like, for example, to be explicit, like, oh, you want some debugging tools or a higher verbose log level. You don't want that in your production containers. You do want them locally, and making sure that you understand what packages are where, and the ability to, in production, actually access those things. So I think that's really cool. And it's a really good point. One thing that we wanted to touch on a little bit, and maybe John can speak to this a bit. So you started this cool project, Docker Slim. You guys have worked together for some time. What made you guys to start Slim.AI itself? Like, how did that get going? What's the story there?
So, as Kyle mentioned, and as we preluded, there are a lot of these, challenges around shipping secure applications to prod, right? And, if Kubernetes is the organism, containers are the cells, right? And of course, Kyle and I have been building very large scale, very important, I'd say in general, cloud native security applications. These are the kind of cloud native applications that secure other cloud native applications and secure very large sets. At the last company we were at before this, our cloud native application that we were involved with had more than 100 million users being protected by it worldwide. Very large scale. And we were building all containerized. We had a very large team, a very wide team, separate, kind of working on that DevOps kind of mindset. You build it, you own it. And, we were really engaged in the thick of this problem to maintain like consistency across all these teams and ensure that, like, from the developer's desk looking out, we were building the secure and most well composed applications as we could. And, again, of course, we had every tool available, but we ran into conditions there where, regardless of like every resource in the world, every tool in the world, we were stuck with bloated containers and inability, sometimes even because they were so large, we couldn't like run them in the latest platform. Tons and tons of vulnerabilities and, lots of software lifecycle scrutiny on vulnerability reduction. So we had to do the really hard work to get these things secure. And, we were always lamenting about, we wish we had higher velocity in building secure apps natively. And we'd been in security, in building security products and companies for a long time. So Kyle, we were together. He mentioned this project, Docker Slim, to me while we were meeting one time, and reminded me that it exists and said, hey, it looks like it's catching on. It's pretty cool. And then we had a number of conversations. I took a look at it. We started talking to some of the users. And as we, started to brainstorm and imagine, first of all, why are users adopting Docker Slim? Kyle had this great base of users that were kind of like ardent fans of it, and adoption and the number of stars was rising. As we dug into that more and started to think about the implications of why and talk to users, it was a pretty clear signal coming out of that. Is that, of course, lots of folks struggle with this combination of like lack of expertise, managing complexity, and dealing with security of containerized applications. It's kind of, we can't secure it because it's hard, and I don't have the expertise. I think Kyle mentioned this earlier. Like hardening is like an expert task. The other part about it is doing the work to secure containers as containers. It's kind of a job that doesn't fit, right? It's like, I'm an engineer. I write code. I want to go fast at writing code. I don't want to prematurely optimize things in my environment, but I would love to ship secure containers if it's easy. And lots of engineers don't have the knowledge or capacity or time to do it well. And so usually this stuff gets kicked down the road. Somebody in SecOps or, somebody downstream kind of figures out they need to secure it. And then you try to wrap security around things later. Or worse, there's a kind of this delayed signal that comes back to the engineering team that says, you got to fix that, but it's always inconvenient. And so we thought, wow, this is kind of, we see users of Docker Slim trying to tackle those problems and be more proactive, like Kyle was mentioning. And we could completely empathize with the problem space, given our own experiences in building cloud native security applications for a long time. And then, kind of, we're entrepreneurial and, we've been doing this a while, building companies and such, and started to explore the idea that Kyle's vision and reasons he built this is a pretty market wide problem space, and that there really wasn't technology aimed at this kind of proactive, automated automation that starts with developers moving out. And so, we kind of put together our ideas. We got together with some other friends of ours that had built companies with us before. We've been part of building companies or in those companies. And we, this was around about 2020, and I decided to go and do it, and left what we were doing and started this company and haven't looked back since. Kyle, you want to add to that or embellish that commentary?
A couple of things to add. So one of the challenges that I've observed over and over again is that one of the problems that prevents developers and engineers, the engineering teams from getting to the production-ready containerized applications and cloud-native applications in general is actually understanding the application. Truly understanding the application.
So you mean from like an architecture perspective, or what do you mean?
In terms of what it needs at the infrastructure level, in terms of the resources it needs, the interactions it has.
So from like a networking perspective, who do I need to talk to? Obviously, there's firewall rules, or maybe using a mesh, or how many replica sets do I need to have? Okay, obviously,
or even more simpler, like what parts of the operating system does it need to run?
Yeah,
right. That's an important hardening question.
And also, for example, what kind of resources the application needs. For example, it needs a lot of memory or disk space or CPU, like any kind of way you slice it. There's not enough knowledge about it. There might be some kind of high-level knowledge about the application the developers themselves have, but the applications are like icebergs. You see only the tip of the iceberg, and in order to have the application running in production, you need to understand what's below the waterline, and that's a manual process.
Right. So it's really the DevOps perspective that you're kind of taking when you're looking at applications, especially the containers as a whole. That totally makes sense. I actually have a slide in my deck that is an iceberg. I don't know if you saw that, or you came up with that on your own, but I really appreciate the iceberg analogy. That is, production is just that little bit of tip on the top, and the rest of it is you don't even want to know. And that goes for the software development lifecycle, let alone the various components and containers that you're using. One other question I did really want to understand about Slim is like just a little bit on the technical side. Just walk me through high level, kind of low level, I guess. So I'm over at Shipyard. We use, maybe I shouldn't say this because it's actually a attack vector, but we use, I don't even know what image we use. I'm pretty sure it's Debian flavored. And we do some of our own Python stuff, and we've got some Go binaries that we have in other places in our stack. Would I actually just go and I would run Docker Slim as like part of my CI process? And then if I did do that, how does it validate that you're not actually taking something out that I actually need? Like that to me is really interesting. Like, how do I give you a Docker file and then you guys give me back a Docker file that is more efficient, slimmed down, and more secure? Like, what's kind of the technology workflow there? So
we have two parts. We have Docker Slim as our open source project, and we have Slim.AI, portal.slim.dev, which is our SaaS. And we have a bunch of free tools there. And so depending upon the kind of scale and scope of the implementation, Docker Slim or Slim.AI might be more appropriate. In the first part that you said, like if I want to plug this into my CI/CD, into my DevOps workflows, then that's more appropriate to do with Slim.AI. And what Slim.AI does, it's got a natural integrations built on it. It's a SaaS platform application, and it connects into any registry, public and private registries. It also has APIs and other kinds of integration points where you can easily connect it to, say, GitHub Actions or whatever you like. And through those APIs and registry interactions, users of that platform can provide access to where their containers live or where their containers are being built, et cetera. And in that case, if you were trying to do this kind of more proactive, automated automation and evaluation, and this is the way it's being used quite a bit, is that you'd kind of create a workflow through your CI/CD you'd make a connection to your private registries where your private containers are, or maybe even a public place, and you would trigger every time something's built or something changes for us to pull that container into our pipeline, evaluate it, and then act on it, harden it, optimize it, vulnerability scan it, you name it. We can do all these things.
So you guys pull in my images, not my Docker file. Is that what it is? So you would connect to my registry?
Yeah, connect to registries, right, exactly. And Docker Slim is different. I'll get into the minute differences there. But anyway, for an integration at scale into pipelines, et cetera, portal.slim.dev is what you need. And that allows kind of fast integration and a lot of assistive tooling and vulnerability scanning, and you name it. It's gives a very refined and complete environment so that you can not only scan and learn, but you can do things like understand changes between two containers, vulnerability differences between two containers, optimize the container, show the differences between the hardened and regular and kind of like pre-slimmed container, et cetera. So it gives you a lot of evaluative tooling that developers can use to see what changes, and that was part of your question. And then you can automate this at scale and go fast. You asked, how do I know you're not taking out stuff I don't need? And that's the magic in this. Kyle was talking about application intelligence kind of loosely. We watch your containers run while they're being stimulated, and then we observe the resources they need. And then when we create a new container, we only remove the parts that aren't necessary for the successful operation. So we emit a new container that is a functional replica of the original, but doesn't have any of the parts you don't need. And you have the ability to tune that and optimize the profile around that. But mostly that knowledge comes from watching them run. And we have a mode of the tool where you can actually receive a container that has instrumentation in it from us through that automation process, and then go run it in your test environments, wherever you'd like. And then we can interact with the results from where you've run that. So there's lots of tools and techniques we have that are made to build a confidently hardened container that can be automated and proactive.
So I run it in my test environment as a way to exercise all of the functionality of the application so that you can observe that. I assume that's the value in me actually running it, right?
Yeah, there's a little bit more to it, and I'd like to go back to the company name, Slim.AI. AI actually stands for application intelligence, and like John mentioned, and that's really the main difference between a lot of tooling in the cloud native space that's more infrastructure centric, focusing on the application itself and building that application intelligence really allows us to automate a lot of activities that you would do manually. And the application intelligence is collected in many different ways. And that also includes static analysis of the application and the container, and also dynamic analysis of the application and the container where that application is running. And on the interaction side of things, we're obviously benefit from using the tests that you have, the integration tests, the end-to-end tests, but we also have built-in probing, automated probing capabilities that also makes it possible for us to see what the application is doing and what it needs and all of that.
Is that eBPF? Because I love talking about supply chain and I love talking about eBPF on every episode whenever possible. Are you guys using eBPFs for those probes?
It's different kinds of probes. Those are more application interaction probes. And eBPF fits better on the sensor side. So we have a sensor that is responsible for collecting telemetry. The current sensor we have is a container level sensor. And we'll be expanding to a model where we have a system level sensor. And the difference there is that the container level sensor is embedded in the container image itself. And the system level sensor lives outside of the containers that you have. And there are a lot of interesting opportunities, but also trade-offs and constraints. For example, with the BPF, you have kernel dependencies in terms of what can be done with the BPF based on the version and all of that. So it's a trade-off based on the application environment that you have.
Of course. Yeah, no, I don't know how much you listen to the Kubelist podcast, but I love to talk about eBPFs and supply chain. And I also love to talk about WASM because I'm like a CNCF hipster over here.
I had a presentation at the last KubeCon about the eBPF libraries and building applications with the BPF. actually. So I'm happy to talk more about that as well.
Oh yeah, I think we definitely do. eBPF is definitely pretty popular in this ecosystem. But before we do, I want to kind of go back, right? Like you talk about this hard problem to solve. John, I think you actually described it in your intro as we're going to explore, understand, and secure containers, and then you just said that you're doing that for both first and third party container images. Obviously, this is a hard problem to solve. We talked a little bit about like the transition to cloud native ecosystem and the separation of like SRE and app dev zone and the infrastructure kind of creating this need. There's other folks in this space though, right? Like Slim is doing a great job, but like there's Sneak and Sysdig and ChainGuard and Anchor and Aqua and Claire that do similar things, all as open source. We've had a lot of them on the podcast too. And what I want to actually helps me a little bit, just help me understand like the differences. Like what does Slim do that's unique and differentiating in this space that sets like your solution apart from the rest of the competition right now?
I think we're one of the only ones that's focusing on this kind of proactive and automated hardening solution. So we're trying to build tooling that makes that usable and repeatable and automatable for our users and customers. And we're kind of expanding the concepts of that and making use of this application intelligence Kyle talked about to really have our system automatically understand the functional operation of the container, and not just the container. Our system can also work on groups of containers, networks of containers. Think Docker Compose files, and so we can make observations about that, and from that observations do a lot of these securing and optimizing tasks. So we're going to really go deep with that concept, make sure that developers have access to all that. I think there's another part of it that is really important, is that we've spent a lot of energy and time and development on making sure that developers understand this. I said there were 3 parts to best practices, right? Know the software you're shipping, only ship to production what's needed to run your application, and remove as many vulnerabilities as possible. But our goal is to make that something very friendly to developers and to the DevOps folks who live in that sort of create and build space of the DevOps lifecycle. And so our commitment to developer friendly tooling, for instance, if you were to go on our Slim site, our portal, you'd find there, I think, the only kind of functionally useful container differ that can show you exactly what changes between 2 containers. This is designed to demystify change for developers. If you go there, we can do the same with our vulnerability scanning, where you can easily target 2 containers and say, show me the vulnerability changes and the compositional changes between those 2 containers. It really helps folks very quickly answer the question, what changed between stable and latest, for instance? Am I getting more vulnerabilities or less? What did the author of that container change in that? And now how can I set up a profile that kind of optimizes a rendition of that will run optimally in my production?
So John, like I have on that, like you're checking that at CI time, right? So, I think that's ridiculously valuable, what you just described. Like, are we increasing the number of CVEs? Have we decreased the number of CVEs? Because like there's dependencies in the image that aren't in the code that I wrote, to your point, with the 3 things, like I'm not even aware of these dependencies in the image. And all of a sudden there's a new like patchable or unpatchable vulnerability. But the way you just described that really is like, I'm guessing there's more to the solution, and that's what I'm trying to get to here. Like you talk about like at release time, at CI, at build time, like there were this many mediums or high vulnerabilities, and now this next version, there's this many mediums and highs, and here's the diffs of the container image. But like, do you also get into like, a vulnerability that was disclosed a week later after I shipped that image, like continuously scanning them?
Yeah, our system can do that as well. Every time that container builds, we can do what you just described, but then you can also automate our system through the APIs. Remember, I mentioned that we can have connectors going into your registries and such. So our system can be triggered to rescan everything, and we'll be building more automations there that kind of proactively do that. But yeah, we're one dimension of our platform is this vulnerability scanning capability that is like super simple to attach to your registries, and gives you all sorts of power to understand and differentiate vulnerability change, even ongoing vulnerability change. The other cool part about our vulnerability system is it's multi-engine, and we have ambitions to add, pretty much any engine to it. So you not only can scan it, but you can get scan results and perspectives from more than one scanner, which is what we find people really want to do, because not all the scanners are equal, and they have differences. They don't have a full kind of intersection of their findings.
Yeah, that's how, at the end of the day, if you're competing one scanner to another, you want to find things at the other scanner. That's how you differentiate the quality of a scanner. And, for us, we ship software into third party, environments. And, we played that game for a little while where it was this scanner reports this and this scanner reports that. And it kind of turns into, they're all valid findings, but really difficult. So we just said, you know what? This is a scanner. We're going to publish a scanner that we use, and we're going to commit to any high vulnerabilities that this scanner detects. And the idea of multi-scanner is definitely interesting because it gives somebody who's shipping software the ability to kind of say, it doesn't really matter which of the scanners you're going to use. We have scanned it against that.
Yeah, think of the consumer side effect here, right? So for any company that ships containers to their customers who use them in their SaaS, for instance, I think you might fall into that same class. The producer of that container is at the whim of scrutiny based on whichever scanner the consumer decided to use.
Right.
But, based on, there's quite a few of these scanners out there, now you've got to kind of answer questions about all the scanners because you're at the whim of the person who's observing your scans. And I think that increasingly there's pressure on publishers to respond. So we saw that as a kind of an information asymmetry or coordination problem. People producing containers very often want to or need to be able to make observations across a set of scanners. And by the way, those consumers can use our platform as well to see results across more than one scanner. So it kind of speeds up the process of coordination on scan results.
Interesting. So, okay, I want to ask before we run out of time, because we're coming up here, I want to ask a little bit about the open source project itself in regards to who's contributing here. Is it mostly the Slim.AI folks? How's the community doing? How do you determine roadmap? And maybe a little bit what's on the roadmap, and then also if I am super interested, or I'm a person listening to the podcast, how can I start getting involved? What's the right place to go to start being a part of this?
I have a few things there in terms of where the things are with the open source project. Obviously, it's not Kubernetes. Not a lot of projects out there are at that level. Only a few. Kubernetes is an outlier when it comes to the standard projects that are out there. But relatively speaking to other projects, we have a lot of attention. We've had a lot of contributions as well. Some of them are more ongoing than others. So it's not just Slim employees. We had people from other kind of companies or just open source contributors, developers contributing. For example, ARM64 support was added by somebody who had a need on ARM64 machines. So we got that kind of contribution based on an external user. In general, we have quite a few open issues on GitHub, and there's a growing number of good first issues that will be good for new contributors, and a number of feature requests. We don't have a formal roadmap mapped to many years ahead, and a lot of it is really driven by the community asks. And it's very dynamic from that perspective. People ask what they want.
Is the community communicating on GitHub issues particular to the Docker Slim project, or is there other places that I should go to come check out more of what's happening?
So GitHub issues, GitHub discussions, the usual forums on Discord. That's probably the most active one. And then we also have a Slim.AI community Discord server where there's a lot more going on in terms of, a lot of use cases related to the discussions related to the podcast and all of that. So if you want to focus more on that side of things, that's also a great resource.
So the good Discord is I go to Slim.AI, and at the bottom there I click on that Discord, and that's the place to find it.
Yeah, that's a good entry point.
Awesome. The other question around all of that is, early on, you started this project. Was it just you, Kyle?
So during the hackathon, a Docker hackathon, there was a small team that were worked together, kind of 2.5 people. And then after the hackathon was done, it was mostly me for a while. And then as people discovered the projects, they filed issues, and then they made suggestions and contributions. So over time, it kind of grew organically.
So a really nice open source story, if you will, of all that stuff. Now, I believe it's written in Go. Is that correct? Just from
Yes, it's Go.
Super cool. And then, do you wish that it was written in Rust? Just kidding. Joke. Yeah, I'm just really looking forward to trying some of this stuff out. I mean, I know that when I took a look the other day, I was in like a examples repo, I want to say. And I believe that there was a bunch of stats there that were talking about how much you can minify these base images to these smaller images. And that really caught my eye. I obviously talked about at the beginning of the podcast, but I think that's really cool too. And I just want to point out to the listeners, like, I think it's worth, we deal with a lot of containers, and those registries get really big really quickly. So I'm super interested just on that, let alone on the security component of all these things. Do you guys have any community meetings in particular, or is that just more coming up?
We have pretty common, live streams and on Twitch, and we have also, like a pretty vibrant program to interact in our community through Discord, et cetera. And we travel around a lot to KubeCon. We have booths there and such. We go to all these places, and lots of times developers kind of join up with us there. In fact, Kyle and one of our other developers led a Docker Slim hackathon, like literally right at one of these events. So yeah, there's lots of ways to interact.
Yeah, the last KubeCon EU.
Yeah. And so, we're trying to help and, and teach and inform and welcome. And it's pretty fun and open community. Lots of stuff going on there. We have a community leader that is he's full time trying to help make sure our community is being nurtured. And we try to build a lot of new content. We, write a lot of articles and do a lot of live streams, et cetera. And, if you raise your hand or you come into our Discord, we're going to interact with you, and we're going to give you as much love as you'll accept. And so, we're all about making people successful, and we love interacting with people. We learn a ton all the time, and it's fun.
Cool. So just before we wrap up, I think it's always interesting to understand, you guys have raised some money, I believe. That's correct. You're venture backed, I believe.
We are. We've it's public information. We've raised about $41 million in financing in 2 rounds.
I didn't mean the exact numbers, but that's impressive. That's awesome. So right now, you mentioned earlier that you're not monetizing. So as a company, you guys are kind of just heads down, building out this community, building out this product, and getting it as good as can be. Are there monetization plans on the horizon? And also, if that's not appropriate, feel free to say, hey, we'll talk about that in 6 months or a year. But I was just curious to ask if
I can give you some high level concepts there. I won't get into too many details, but as we've talked about, we started really investing a lot in the core technology and the open source, and then that's really taken off and grown. We've got like 15,200 stars now, and the project has just been really successful. Tons and tons of downloads. I think more than 500,000 downloads, et cetera. So Docker Slim certainly taken off and been a great project for us to really explore and learn and interact with great developers and just, kind of, I think, produce some really good stuff for the community. We then switched phases into building out the nucleus of our SaaS capabilities. And it's always been our intention to kind of make that a companion to the needs of folks who've been doing Docker Slim in helping them go from a kind of local tool that's mostly command line that they can use, to work on images in their local environments, to something that allows them to scale and interact with containers in a much more, user-friendly and integrated way. And then we've brought a lot of analytics and tooling and parts of the core engine of Docker Slim in there so that you can start to perform workflows and use cases that kind of allow you to build this kind of automated, proactive security and assessment and hardening and optimization kind of flows. And that free tooling you can go and sign up right now if you want on portal.slim.dev is widely adopted. So thousands and thousands of users come there, and it's like growing faster every month, and we're getting a ton of interest and adoption. And in the Slim Discord, we've got mix of users in there, like from our free and SaaS and from our open source, kind of a group hug there across the board. We are, of course, working with, and you'll see it on there on our website, join and become our design partner. We're working with a whole bunch of quite a few design partners who are working with us to evolve what I'll call our pre-commercial solution. This is like a more enterprise-ready, organization-ready solution building from our SaaS that we've had out there for about a year. So we're in that process right now, really working through and making the solution awesome and doubling down on a bunch of core value propositions and workflows, and really just experiencing and interacting with users who use it every day, and plug it into these workflows and trying to reach some of the objectives we talked about. So moving into a more commercial period is our next phase. We've got some work ahead of us yet to continue to refine and optimize and expand our solution. And of course, we want to build awesome products. So, it's coming. I can't say when, but we are definitely moving in that direction.
Yeah, we're trying to monetize the supply chain value for the enterprises because there's a lot of demand there. And there's one more thing I wanted to add. We have a Docker desktop extension, which is also great for developers, a great way to experience Slim and get value locally, and also get some of the cloud value as well.
Yeah, no, I mean that makes a whole lot of sense. The supply chain stuff's been on all of our minds for some time, especially with SolarWinds and all these other things that have been going on. But I think that's a really burgeoning space to be looking at. All right, well, guys, it was really great having you on. And really appreciate you guys taking the time, and look forward to meeting you face to face and watching where Slim and Docker Slim and Slim.AI go.
Thank you very much.
Thanks a lot.
That's all we have time for today. If you're interested in being a guest on this show, or if you would like to suggest a topic, head over to Kubelist.com. I'm Marc Campbell, CTO at Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem applications to their largest enterprise customers. Check us out at Replicated.com. My co-host is Benjie DeGroot, CEO at Shipyard, where they enable isolated ephemeral environments on every code change for companies of all sizes. Check them out at shipyard.build. This show is brought to you by Heavybit, the leading investor in developer-first startups. For more information, visit heavybit.com. And finally, don't forget to sign up for the Kubelist weekly newsletter and read previous issues at Kubelist.com.